real reason to believe that this is different. Do we? No. It's basically all, S1 and S2 are basically all composed of the same chips, just with different signs. So therefore their norms should be the same. So this is equal to 7NC. And we end up with root 7NC plus 2 times NC over 7, excuse me, minus 2 times NC over 7 plus NC over 7, so that's minus NC over 7. And if you want to take that the last step, that would be root 7 times 7 is 49 divided by 7 minus 1, which is 48 NC over 7. So we end up with Sy is equal to S2 minus, excuse me, plus root NC over 7SX divided by root 48 NC over 7.
Is there a reason why you didn't substitute NC? It's not really general, but you're still depending on the chip sequence, right?
That's true. No, I guess there's not really a good reason. So what do we get? We get this. If I look here, I can express S1 and S2 in terms of my orthonormal bases. So S1 is equal to root 7 NC times SX, and S2 is equal to root 48 NC over 7 times SY minus root NC over 7 SX. Okay, let's pick a value for NC at this point. So let's say the easiest thing that I can see to do would be, let's say NC equals 7. So what would we get? S1, 7 times 7, which is root 49, which is 7, SX. I'm going to keep it as root 49 for reasons which will be obvious in a second. And S2 is root 48 times 7 over 7, so that's root 48 SY minus square root of 1, which is 1 SX. So I kept it as square root to show that this is slightly shorter in the y direction. But actually it's not sufficiently much shorter to really worry about. So I'm going to plot this in a second. So this is equal to 7SX, and this is approximately equal to 7SY minus SX. Because root 48 is just short of 7. Okay, so let's plot this in signal space. Now we can do everything that we can bring all of the analysis to bear that we've already used. And we remember that our coefficients in front of S1 and S2 are plus 1 and minus 1. So actually, let me write out my 4 signals before I sketch this. So User 1 can send a +1 or -1. User 2 can send a +1 or -1. So my four signals are plus S1 plus S2, which is, I'm going to use this approximation just because it's easier. So that's, that would be equal to 14SY minus SX plus S1 minus S2. Excuse me, that's not correct. That would be 7SX plus 7SY minus SX, which is 6SX plus 7SY. So in other words, in signal space, this is at point 6, 7. Plus S1 minus S2. Okay, plus S1, I have 7SX. Minus S2, I have minus 7SY plus SX, so I have 8SX minus 7SY. So in signal space, this is at point 8 minus 7. Minus S1 plus S2. Okay, minus S1. I have minus 7SX. Plus S2, I have plus 7SY minus SX. So I have minus 8SX plus 7SY, which is at point minus 8 plus 7. And finally, minus S1 minus S2. Which is minus 7 SX minus 7 SY plus SX, so that is minus 6 SX plus, excuse me, minus 6 SS minus 7 SY. So this is that point, minus 6 minus 7. Okay, now let's sketch it in signal space. So the first signal, plus 6 plus 7. I'm going to need 8 points here. 7 vertical. So this is Y, this is the SY direction, and this is the SX direction. So my first point is at plus 6. 5, 6 plus 7. 1, 2, 3, 4, 5, 6, 7. There's my first signal. My second signal is at 8 minus 7. 6, 8. So it's obviously askew just a little bit. My next signal is at minus 8 plus 7. 6, 8 plus 7. And my final signal is at minus 6 minus 7. So minus 7, 6, minus 7. So I have this slightly askew box. Whereas before everything was rectangular, now I have this slightly askew arrangement. So what you would find